Hello everyone, welcome back to mychemcorner. So in this video we're going to talk about another topic in the chapter solutions. So if you're new to this channel, please don't forget to subscribe and hit the bell icon so you receive notifications as and when I upload the video. So let's move into today's topic. So in this video we're going to talk about solubility of a solid in a liquid and solubility of a gas in a liquid and the laws that are going to govern these solubility and factors responsible for solubility. So here when we talk about solubility of a solid in a liquid, we should remember that not all solids are dissolving in a particular liquid. So for example, when you go to your lab and you try doing salt analysis, we have learned that in salt analysis we have two types of salt. One is crystalline salt, the other one is amorphous salt. And we know what the solubility is because a crystalline salt is soluble in water and amorphous salt is soluble in dilute HCl. So if you see, the solubility is not the same, though both are salts. So here salt dissolves in water but anthracene and naphthalene dissolves in benzene. So example is, if you take the naphthalene ball that you have at home and try to put it in water, nothing really happens. It's not going to dissolve. So it has its respective solvents in which it can dissolve. So to just conclude the entire thing, we can say that polar solutes are dissolving in polar solvents and non-polar solutes dissolves in non-polar solvents. So when you talk about the solubility, we basically include two processes. One is dissolution. This is when a solute is added to a solvent, some of the solute dissolves and its concentration is going to increase in the solution. That is basically what your dissolution is. Now we are talking about crystallization. In this case, some of the solute particles in the solution collide with solid particles and they get separated out. It's one of the purification technique. Right? So here also you have solubility. Alright. Now, till when will this solubility take place? A stage will reach when both processes will take place at the same rate, which is the equilibrium state. And we can also call another type of solution called as saturated is when you keep adding solute and there will be a point when no more solute will be dissolved in the solvent. Such kind of solutions are called as saturated solution. This is one type of a solution that you prepare in practicals to prepare original solution. That is a saturated solution. So here basic solubility of a solid in a liquid is the same, but only thing is because we move in depth, we need to know that not all salts or not all solids are soluble in a particular liquid. They have their own solubility criteria. Alright, so now if you're looking at what is the effect of temperature on solubility, right? So here solubility of a solid in a liquid is affected by a change in the temperature, increase or decrease in temperature. Now when we learn about this factor, we always come across one particular topic, which is equilibrium. And in equilibrium, the law that actually governs all this is Le Chatelier's principle. Right? And when we talk about Le Chatelier's principle, two types of process that always comes in mind is exothermic and endothermic process. So here, if the process is endothermic, what do you mean by endothermic? Endothermic meaning the process that will absorb energy. That is endothermic. So when the system is already absorbing energy, I am trying to give more energy by increasing temperature. What will happen? The solubility is only going to increase. This is like a hungry child is waiting for food. If I give more food, the child will keep having food, right? Same way, the system is ready to take in. So if I increase temperature, which means solubility is also going to increase. Opposite to this is what your exothermic process is. Exothermic meaning that there is a release of energy. The child is full. The child doesn't want to eat food. But what am I going to do? I'm going to give more food for the child. But will the child actually take? No, the child will refuse food, because the stomach is full, right? Same thing here. The system is releasing energy. To such a system which releases energy, I am going on increasing energy. I am going on increasing temperature. The system is not going to accept. So therefore, what will happen? It will not get solubilized. The solubility will only decrease. Alright. So this is the effect of temperature it has on solubility. Next is effect of pressure. Since we are learning solubility of a solid in a liquid, when you look at solids, pressure really plays no role because solids are incompressible, right? They have a close packed structures, which we learnt in solid state in the last chapter. They have a very close packed structures. Molecules have very small intermolecular distance between them. Their intermolecular force is so strong that the molecules are very close to each other. So because of all this factor, there is no effect of pressure on solubility. Alright, so that was all about solubility of a solid in a liquid. Pretty much very easy, because this is something that is very basic. Now the next that we can talk about is solubility of a gas in a liquid. Now this is a topic where you will come across effect of pressure more, because gases are stable at a particular pressure only. If you alter that pressure, then they will start reacting. Right? Because the pressure at which hydrogen is stored is not the same pressure at which nitrogen is stored, or is not the same pressure in which a noble gas is stored. Right? So when you change that particular pressure, gases will start reacting and you can see some reaction out. So the same thing comes with respect to solubility also. So here, solubility of a gas in a liquid is affected by change in pressure and temperature. So in this case, when I start to decrease the temperature, gases are active at a very high temperature. So what you do is, you're going to decrease the temperature. When you decrease the temperature, it will easily have solubility. When you start increasing temperature, what is happening? The system is already active. You increase the temperature, to balance it out, it's going to decrease the solubility. So what happens in this case is, because the gas molecules are already active, they have a very good pressure already. When you decrease the temperature, the solubility is going to increase. But what about with respect to pressure? You need to increase the pressure so that the solubility of the gas will also start increasing. So this is all about change in pressure and temperature with respect to solubility of a gas in a liquid. So these all relations, the relation between solubility and pressure and all, was learnt by a person named Henry. So he has given out a mathematical expression by various research and a law named after him. So the law states here that the solubility of a gas in a liquid, when you try to dissolve a gas in a liquid, that is directly proportional to the partial pressure of the gas present above the surface of the liquid. So when you look at the liquid, on the surface you will have gas molecules, and those gas molecules will exert some partial pressure. So depending on that partial pressure, solubility is also going to be directly proportional, which means the partial pressure of that particular gas increases, the solubility of the gas will also start increasing. Then he spoke about with respect to mole fraction. When you're talking about solubility, you can also talk with respect to mole fraction. So he gave out another statement. In this case also, he says that the mole fraction of a gas in a solution is directly proportional to the partial pressure of the gas present above the solution. So in first case, he spoke with respect to solubility. In the second case, he spoke with respect to mole fraction. Now in the third one, he gave a relationship between partial pressure and mole fraction in the vapor phase. So if you see, he's spoken with respect to the same type of a law in different terminology. Alright, but the meaning of it is the same. So here, to conclude the entire thing, we can say that the mathematical expression for Henry's law is this: P is equal to KH into X. P is pressure, X is mole fraction as usual, KH is Henry's constant. Alright, so now when you keep the solubility as lower, which means the value of KH is going to be the highest. Alright, so higher the value of KH, lower is the solubility of a gas in a liquid. So for solubility of a gas in a liquid, most important law is Henry's law. So here we have a problem based on Henry's law. In this case, it says if nitrogen gases bubble through water at 293 Kelvin, how many millimoles of nitrogen gas would be dissolved in 1 liter of water? Assuming that nitrogen gas exerts a partial pressure of 0.987 bar, given that Henry's constant for N2 is 293, at 293 is 76.48 kilobar. So first in this problem, we are going to write what is given to us. Let's mention that one. So the values that are given to us is, first, pressure is given to us, which is 0.987 bar. Then what is given to us as Henry's constant, which is K at 76.48 kilobar. But because both pressures are there, one is in bar, the other one in kilobar. So I'm going to convert this particular one into bar. So it's going to be 76,480 bar, which is into 1000. Now, from this particular formula, P is equal to KH into X. We know what is P, we know what is KH. It's easy for us to find mole fraction. So X is equal to pressure by KH. Substitute both the values. You will get your mole fraction as 1.29 10 to the power minus 5. There is no unit for mole fraction, so it just remains as it is. So you know what is the mole fraction. From that you can calculate what is the number of moles of water. The compound given here is water. So number of moles of water is given to given mass is taken as 1000 in general, divided by molar mass is taken as 18. When we calculate this, you will get 55.5 moles. So this 1000 is coming that we are going to take 1 liter as in general. So here also the question clearly says 1 liter, which means 1000 ml. In terms of grams, when you take it becomes 1000 grams. Alright, so here we are taking this as 1000. That is a given mass as per the question. Now we know what is the number of moles of water. So in this case, we're going to find out mole fraction of N2 is equal to number of moles of N2 divided by number of moles of N2 plus number of moles of water. So here, number of moles of N2 we don't know. That's what we have to calculate, because the question clearly says how many millimoles of nitrogen gas. That is a question. So in this case, the number of moles of N2 is neglected in the denominator. Okay, to make it more easier, we neglect that particular solute in the denominator. So your formula becomes like this. Mole fraction of N2 is equal to number of moles of N2 by number of moles of water. Now in this formula, number of moles of water we just found out. We have it. Mole fraction of N2, we have found it out over here. So what is left out? Number of moles of N2. That's what the question clearly says. So we just have to substitute the values and get the value for number of moles of N2. But our question does not stop here, because the question clearly says the answer should be in millimole, not in mole. So here the relation between mole and millimole is 1 mole is equal to 1000 millimole. Therefore, these many moles is equal to how much? When we calculate it and convert the powers, we will get 0.71595 millimole. So our answer is going to be this. 0.71595 millimole is the answer. So this way, these are all basic questions. The question might look difficult when we read it, but when we try to put down what is given to us and what is asked to us from the question, we know that the process of solving is the same as what we did in the previous equation, in the previous questions. So I hope this video has been helpful for you regarding solubility of a solid in a liquid. If you have any comments or suggestions, please don't hesitate to put it in the comment box below or email to me in the email ID given in the description box below. I'll see you in the next video, so stay tuned. Thank you so much for watching.